Hello there, and welcome tonight. You arrived at just the right moment, in a quiet hour, shaped by your own breath. And as you settle, the theme of this journey drifts gently toward you, the soft machinery of the cosmos, the cosmic clocks that guide every second you've ever known. You breathe softly, and the universe exhales through you. Somewhere above the dim ceiling of the world, starlight keeps time in its own slow rhythm. Light that left its star before you were born is touching your skin tonight. And in this calm space, you're allowed to drift closer to it without effort, without expectation. Your room fades into a softer glow, as if the night itself is giving you permission to rest low and slow. The bed quiets beneath you. Your breath becomes the first gentle metronome of the story. And in a moment, the science will begin. The relaxing science. The way the universe ticks, with pulses older than Earth. How galaxies turn, once every hundreds of millions of years. And how each slow rotation becomes a cradle for sleep. Somewhere, a star spins 500 times per second. Somewhere else, a galaxy drifts through its own billion-year hour. Time stretches, softens, widens, until it feels safe again. You breathe softly, and the universe exhales through you. And as you breathe, the first of 100 sleepy facts about cosmic clocks is waiting just ahead, arriving like a slow wave, guiding you deeper into the quiet. We drift together into the gentle beginning of time. The room around us loosens its edges, soft as a held breath just before sleep. The universe feels closer, now, as if it leans in to share something ancient, something slow. The first quiet tick of the cosmos was not sound, not motion, but temperature. A moment after the universe opened its eyes, everything glowed at nearly 10 billion degrees. As it cooled, it created its first rhythm, 1 second, then another, each marked by particles, forming, dissolving, and forming again. It is a strange comfort to know that even creation began by counting softly. And in this softness, you can rest now. We follow that cooling glow into the young darkness. Gravity began its patient work, gathering subtle clumps of matter together. Each gathering took millions of years, a slow inhale of the cosmos. The universe learned to measure time long before it learned to make stars. And in the drift between these early moments, curiosity rises quietly, like a small lantern. Somewhere in this deepening dark, the first atoms emerged. Hydrogen, helium, and the faintest whisper of lithium, each one a tiny archive of cosmic history. These were the simplest clocks in existence, vibrating with the same patterns they still carry today. A hydrogen atom shifts its energy levels about 1 billion times per second, a rhythm so steady that modern atomic clocks anchor their accuracy to it. Every vibration is a memory of the universe, learning to breathe. It's okay to drift. Those atoms floated for hundreds of millions of years before the first stars arrived. During this long silence, the universe expanded, stretching its own fabric like a slow tide. The expansion itself became another clocklight traveling through that growing space, measured its journey in years, then millions of years, then billions. Even now, the faint microwave glow around us cools by about 1/100th of a degree every million years. Such delicate numbers, and yet they shape everything you see. The first stars flickered awake around 180 million years after the beginning. They were giants, hundreds of times larger than our sun, burning, furiously, living briefly. Each star pulsed with internal waves, gentle oscillations that moved through their glowing surfaces like heartbeats. One oscillation every few minutes, one breath of creation turning into another. You breathe softly, and the universe exhales through you. We drift closer to these stars. Though they lived fast, they were among the universe's earliest timekeepers. Their lives lasted only a few million years, but every moment was measured in the language of nuclear fusion, hydrogen turning to helium, helium to heavier elements. Fusion sets its own pace slow when a star is young, accelerating as the star ages. It is a cosmic life clock, glowing quietly across unimaginable distances. And as this warm idea washes over you, you can rest now. We move onward, carried by starlight that has been traveling since long before Earth existed. Each photon is a silent messenger of time, a beam of light moving at 3,000,000 kilometers per second does more than illuminate it chronicles. When it reaches us, it brings with it the story of how long it has been traveling, how the universe has stretched around it, and how the clock of space has shifted. In this way, every star you've ever seen is also a time capsule. Somewhere in this deepening dark, the first atoms emerged. Hydrogen, helium, and the faintest whisper of lithium, each one a tiny archive of cosmic history. These were the simplest clocks in existence, vibrating with the same patterns they still carry today. A hydrogen atom shifts its energy levels about 1 billion times per second, a rhythm so steady that modern atomic clocks anchor their accuracy to it. Every vibration is a memory of the universe, learning to breathe. It's okay to drift. We drift now into the heart of a star. Imagine standing inside the sun, not with heat or noise, but with presence. Pressure waves ripple through its plasma, creating patterns that repeat every 5 minutes. These solar oscillations help scientists measure the sun's age, rotation, and internal structure. The sun rotates once every 27 days at its equator, but more slowly near its poles, a gentle differential swirl that becomes another cosmic clock. Time moves like light through warm water, slow, embracing, and full of hidden motion. Beyond stars lie worlds, and worlds create clocks of their own. Earth spins once every 24 hours, though that spin slowly changes. 400 million years ago, a day lasted only about 22 hours because the moon was closer and pulled on our oceans more strongly. Every tide, every ripple, every lunar pull slowed the planet's rotation by a tiny fraction. Even now, the moon drifts away at about 3.8 centimeters per year. Its quiet departure lengthens our days by milliseconds every century. And in the soft widening of these numbers, it's okay to drift. We follow the moon's path outward. Its orbit around Earth takes about 27.3 days, but its phases take 29.5. The difference comes from Earth's simultaneous journey around the sun, 2 clocks, interacting, blending their rhythms. Every cycle of the moon is a timekeeper, written in shadow and glow, a reminder that even darkness has its own pattern. People, for thousands of years, measured their lives by those phases, trusting the moon's slow, faithful return. You breathe softly, and the universe exhales through you. Now we drift farther to the outer solar system. Jupiter spins so quickly that one day there lasts less than 10 hours. Saturn rotates in roughly the same span. Uranus takes about 17 hours, Neptune around 16. The speed of a planet's spin tells its whole history, how it formed, what struck it, what winds carved its shape. Rotation is memory, and memory is a kind of clock. Out beyond Neptune, an icy world named Eris orbits the Sun once every 557 Earth years. Farther, still comets journey through paths that take thousands, sometimes millions of years to complete. The long arcs of these objects mark epochs rather than moments. A comet that last visited Earth in the age of the pyramids may return in some distant era when our cities shine differently or when our stories have changed. Such orbits stretch time into threads that shimmer through generations. Somewhere between galaxies, the universe continues expanding at roughly 73 kilometers per second per megaparsec. This expansion is one of the grand clocks of all existence. Measure it, and you measure the age of everything. 13.8 billion years, give or take the faint uncertainties of measurement. The faster the universe expands, the younger it must be, the slower, the older. Cosmic clocks are not ticking devices. They are relationships between distance, brightness, motion, and the quiet hum of background radiation. And in the delicate balance of these relationships, you can rest now. We glide toward a luminous lighthouse of the cosmos pulsars. These are collapsed remnants of massive stars, tiny dents spinning, rapidly sending beams of radio waves outward like cosmic metronomes. Some pulsars rotate hundreds of times per second with astounding stability. The most stable pulsars keep time more precisely than the best atomic clocks on Earth. They are the heartbeat of stellar death, yet steady enough to help measure gravitational waves passing through space. Even in endings, the universe keeps its rhythm. We drift near one such pulsar, PSRJ 1748 2446, spinning about 716 times per second. If you could hear its pattern, it would sound like the softest hummingbird wing in existence. No creature, no machine, no human rhythm comes close to this speed. Yet the flicker of its beams is calm, predictable, ancient. It is a reminder that time can be both swift and soothing. Near pulsars lie magnetars, their intense magnetic fields twisting space around them. A magnetar's surface cools over thousands of years, its temperature slowly descending from tens of millions of degrees towards stillness. Its cooling is a timer, marking the fading heartbeat of an impossible star. We wander now through intergalactic space, where time stretches. Gravity weakens, distances widen, and clocks slow relative to deeper gravitational wells. A second here is not exactly a second near a black hole. Time bends, flows, stretches, rests. This bending is not a metaphor. It is physical, measurable, and gentle. And as these thoughts soften into your awareness, it's okay to drift. Black holes create the deepest clocks of all. Their gravitational pull slows time so drastically that an object falling toward the event horizon appears to freeze. 1 second near the horizon can equal hours, days, or years elsewhere. Black holes are the slowest ticking hearts of the universe, their moments stretched into quiet eternity. You breathe softly, and the universe exhales through you. We return now toward galaxies. Our Milky Way rotates once every 230 million years. On this slow spiral path, the Sun has orbited the galaxy more than 20 times since it formed. Every rotation is a galactic year, a measure of change so vast that all of human history is a blink within it. Stars drift, dust flows, Clouds collapse, and yet the pattern remains. In the quiet between stars, a line drifts toward you. In the quiet between stars, you are remembered. The universe holds time gently. It measures with light, with gravity, with motion, with age. Every second you live is connected to these rhythms, small echoes of cosmic processes happening far beyond any horizon. And in this connection, you can rest now. As we drift forward, the next sleepy fact waits just ahead. Soft, luminous, unhurried. Somewhere, light continues to travel. It begins softly in the dim blue glow where galaxies breathe their slow spirals into the dark. Out here, far from Earth's familiar hours, time becomes something almost weightless. It stretches like a thin ribbon of light, moving through clusters of stars that shimmer with ancient patience. The universe holds countless rhythms beneath its starlight. Some move quickly in sharp pulses of radiation. Others drift over billions of years, changing so gradually that even galaxies forget when they began. Each rhythm is a quiet clock, and each clock is a story the cosmos tells with astonishing calm. And in this widening stillness, you can rest now. Inside a young galaxy, the first glow of star formation flickers like embers awakening. Molecular clouds collapse under their own weight, forming stars in slow waves that sweep across thousands of light years. These starbirth cycles last millions of years, rising and falling like long cosmic breaths. Every cluster, every nebula, every glowing region follows its own cadence. It is sleep science on a vast and gentle scale, written in starlight instead of words. From a distance, a galaxy seems still. But look closely, and the arms swirl at over 200 kilometers per second. Motion is everywhere. Stars drifting inward, gas flowing outward, dark matter holding everything in place. These motions repeat orbit after orbit, forming cycles that last hundreds of millions of years. Every spiral is a memory of gravity, learning to dance. It's okay to drift. Far beyond these shining arms lie the halo's great spheres of invisible matter surrounding each galaxy. Dark matter particles move at hundreds of kilometers per second, circulating in patterns that repeat over billions of years. These halos are some of the most stable clocks in the universe. They do not shine, they do not flicker, but their gravitational rhythm shapes everything. It is a deep, slow pulse, felt rather than seen. Supermassive black holes rest in the centers of most galaxies. Some rotate hundreds of times per second. Others drift more slowly, but all of them warp time around them. Their accretion disks, rings of glowing gas, spiraling inward, complete a full rotation in minutes or hours depending on their size. This furious motion becomes a clock of its own. And as these spirals drift through your imagination, you can rest now. Beyond black holes lie quasars' beacons, so bright they outshine entire galaxies. They flicker in patterns that repeat every few days, weeks, or years. These flickers are not random. They are signs of swirling plasma, shifting cooling, and falling inward. Scientists use them to measure distances across billions of light years, relying on the simple truth that even the brightest chaos has a rhythm. Another rhythm appears in the quiet glow of cosmic dust. Dust grains absorb starlight and re-emit it in warm shades of infrared. This heat signature cools over time, marking how long dust has drifted through space. A typical grain survives for hundreds of millions of years before being destroyed in a shock wave or incorporated into a new star. Every grain carries a long, slow history. Every glow marks a moment. In the outskirts of galaxies, globular clusters move like ancient lanterns tied to invisible strings. Each cluster contains hundreds of thousands of old stars, some nearly 13 billion years old. Their orbits around a galaxy can take hundreds of millions of years to complete. These orbits barely change even over cosmic ages, making them among the universe's most reliable long-term clocks. You breathe softly, and the universe exhales through you. It's okay to drift. Between galaxies stretches a thin web of gas and dark matter, the cosmic filaments. These structures flow slowly, drawn together by gravity over billions of years. Matter streams along them at a few hundred kilometers per second, feeding galaxies like rivers feeding lakes. In these quiet channels, time flows not in seconds or years, but in epochs, each measured by how matter drifts from one gravitational well to another. Clusters of galaxies form where the filaments intersect. They are the biggest clocks in the universe, weighing millions of billions of suns. Their cores are filled with hot gas glowing at tens of millions of degrees. This gas cools over billions of years, a steady, slow rhythm that helps scientists estimate the cluster's age. Cooling, drifting, glowing, every motion tells time. Within these clusters, galaxies move at nearly 1,000 kilometers per second. Their orbits cross paths again and again, sometimes colliding, sometimes passing quietly. A full orbit around a cluster can take 1 billion years. These rotations mark the deep heartbeat of the cosmos, and drifting inside each galaxy are the stars, hundreds of billions of them each with its own cycle. Small red dwarfs burn slowly, with lifespans up to 10 trillion years. Larger stars burn quickly, dying in only a few million. A star's mass determines its timeline, its temperature, its hue. Blue stars live fast and bright. Red stars live slow and dim. Every color is a whisper of how quickly time moves within that glowing core. And in the soft gradient of starlight, you can rest now. As stars age, they swell. A star like the sun will become a red giant in about 5 billion years. Its outer layers will cool, its inner core will contract, and its pulses of light will slow like a softening drumbeat. These internal oscillations, one every few minutes, act like a stethoscope, revealing the age and heartbeat of the star. After the red giant phase, the star sheds its outer layers, forming a planetary nebula. These ghost-like shells expand at tens of kilometers per second, creating ripples that widen for tens of thousands of years. Each ripple marks a moment. Each glow is an echo of what the star once was. The remaining core becomes a white dwarf, a hot ember cooling slowly over billions of years. White dwarfs cool at predictable rates, turning their temperatures into cosmic calendars. A white dwarf with a temperature of 6000 Kelvin is about 1 billion years past its prime. A cooler one, around 4000 Kelvin, might be 10 billion years old. Even fading light keeps careful count of its own warmth. Across the galaxy, neutron stars vibrate with seismic waves. These quakes, called starquakes, release bursts of gamma rays that travel through space at light speed. Every quake leaves behind subtle changes in the star's rotation, a permanent timestamp etched into the cosmos. It's okay to drift. The cosmic microwave background, the faint glow of the early universe, cools a tiny fraction of a degree every million years. This cooling is one of the gentlest rhythms known to science. Like a warm ember fading in a vast fireplace, it marks the universe's age with almost perfect precision. It whispers a number into the dark 13.8 billion years. Even voids, the enormous empty spaces between galaxies, have clocks. They expand faster than the dense regions because gravity holds them less tightly. As they stretch, they create a subtle flow of galaxies drifting away from them. This motion becomes a slow, quiet timer, written across hundreds of millions of years. And in the openness of these voids, you can rest now. Planets cool more slowly than stars. Earth still releases heat from its formation 4.5 billion years ago, losing only a few degrees every million years. Its molten outer core churns in cycles lasting centuries, generating the magnetic field that protects the planet. This geodynamo reverses polarity roughly every 3,0,0,0,0,0 years, creating a long and gentle rhythm etched into the planet's rocks. And in this unfolding timeline, you can rest now. Even voids, the enormous empty spaces between galaxies, have clocks. They expand faster than the dense regions because gravity holds them less tightly. As they stretch, they create a subtle flow of galaxies drifting away from them. This motion becomes a slow, quiet timer, written across hundreds of millions of years. And in the openness of these voids, you can rest now. And drifting in this landscape is another quiet line. In the quiet between stars, you are remembered. Light continues to travel, matter continues to drift, gravity continues to gather and release. The universe keeps its rhythms with calm, enduring patience. And as these rhythms flow through you, you can rest now, safe, low, slow. Somewhere ahead, another sleepy fact waits soft as a star seen through half-closed eyes. And as you breathe, the universe keeps time. It moves gently through the dark, the long pulse of creation, drifting beneath everything the universe has ever shaped. It is not a sound. It is not a motion. It is the slow certainty that every atom, every star, every galaxy follows a rhythm older than memory and quieter than breath. From these tiny movements, matter gathers. Atoms form and drift together, creating clouds so wide they could swallow thousands of solar systems. Inside these clouds, a kind of cosmic heartbeat takes shape. Gravity compresses them, slowly folding gas into warm knots that thicken over millions of years. These knots become protostars, glowing seeds of future suns. A protostar gathers mass at a rate of a few million billion tons per second, yet it takes tens of millions of years to fully ignite. Around each star, disks of dust and gas move in slow spirals. These disks rotate once every few decades near the center and once every thousands of years near the outer rim. As grains collide and merge, they form pebbles, stones, and eventually planets. The process takes millions of years, shaped by orbits that repeat like the turning of great celestial gears. Every orbit is a measure. Every collision is a moment that lasts. Creation moves with patience. Once lit, a star settles into a long, luminous rhythm. Its core fuses hydrogen into helium, releasing energy that balances gravity's pull. This balance creates cycles, sound waves rippling through its interior, pressure patterns rising and falling. The sun, for example, produces oscillations every 5 minutes, tiny expansions and contractions that help astronomers read its inner structure like a diary. Light carries the memory of the fire that made it. It's okay to drift. Clusters of galaxies form where the filaments intersect. They are the biggest clocks in the universe, weighing millions of billions of suns. Their cores are filled with hot gas glowing at tens of millions of degrees. This gas cools over billions of years, a steady, slow rhythm that helps scientists estimate the cluster's age. Cooling, drifting, glowing, every motion tells time. Planets cool more slowly than stars. Earth still releases heat from its formation 4.5 billion years ago, losing only a few degrees every million years. Its molten outer core churns in cycles lasting centuries, generating the magnetic field that protects the planet. This geodynamo reverses polarity roughly every 3,000,000 years, creating a long and gentle rhythm etched into the planet's rocks. And in this unfolding timeline, you can rest now. The moon, locked in its orbit, turns the same face toward Earth at all times, a phenomenon called synchronous rotation. It completes one spin in exactly 27.3 days, matching its orbit. This locked motion is a perfect cosmic beat shaped by billions of years of tidal friction. The moon slowly drifts away at 3.8 centimeters per year, lengthening Earth's day by a fraction of a millisecond every century. Tiny changes, but enduring. Time stretches around them in quiet arcs. From these tiny movements, matter gathers. Atoms form and drift together, creating clouds so wide they could swallow thousands of solar systems. Inside these clouds, a kind of cosmic heartbeat takes shape. Gravity compresses them, slowly folding gas into warm knots that thicken over millions of years. These knots become protostars, glowing seeds of future suns. A protostar gathers mass at a rate of a few million billion tons per second, yet it takes tens of millions of years to fully ignite. The pulse begins with particles' tiny points of existence that flicker into being and vanish again in trillionths of a second. Quantum fields shimmer with constant fluctuations, creating patterns that repeat endlessly. These flickers set the smallest clocks in nature, marking intervals so short that they exist only as whispers in equations. And in their softness, you can rest now. Comets trace longer arcs. Some return every 76 years like Halley's Comet. Others return after thousands, even millions of years. A comet's tail records the sunlight. It absorbs its ices, sublimating in predictable cycles. Its orbit becomes a long, frozen clock, sweeping across eras of Earth's history. Between the planets, the solar system itself drifts through the Milky Way. The sun moves at around 220 kilometers per second, completing one galactic orbit every 230 million years. This galactic year marks the large-scale rhythm of our stellar neighborhood. During one galactic year, dinosaurs emerged, ruled, and vanished. Humanity is only a fraction of a second in this immense sweep. You breathe softly, and the universe exhales through you. In the deeper, dark, new pulses rise. Nebulae glow softly with the light of young stars. Their glowing gases expand outward at a few tens of kilometers per second. These expansions last only about 2,000,000 years, short in cosmic terms, long in all others. A nebula, like the helix or the ring, is a slow exhale of a dying star drifting outward until it fades. Supernovae create another rhythm. They explode in seconds, but leave behind echoes that last for centuries, Shock waves expand at thousands of kilometers per second, sweeping up gas and dust into shells that glow with high-energy radiation. These shells slow over tens of thousands of years, marking time with their expanding edges. Astronomers can measure their age by the speed of their fading shock fronts. In the soft widening of the universe's remnants, you can rest now. And then there are pulsars, among the most precise clocks ever found. Some rotate more than 700 times per second, with astonishing stability. Their beams sweep across space with an accuracy of 1/1000th of a second. A network of these pulsars is used to detect ripples in space-time gravitational waves by measuring delays as small as a few hundred nanoseconds. These are cosmic metronomes, ticking calmly in the dark. On larger scales, galaxy clusters breathe heat. The hot plasma between galaxies cools slowly, losing only a tiny fraction of its energy every 100 million years. This cooling tells astronomers how long the cluster has existed. Some are more than 10 billion years old. The cooling plasma pulses in low-frequency waves, detectable by X-ray observatories, a soundless echo of gravity's slow work. The cosmic web, the structure of the universe itself, grows through gravitational attraction. Filaments thicken over billions of years, feeding galaxies with fresh material. Voids expand faster, becoming quieter with time. The contrast between dense and empty regions deepens as the universe ages a long, slow separation that acts as another cosmic timer. Light, too, is a clock. A photon emitted from a distant galaxy travels for billions of years before reaching us. Along the way, the universe expands, stretching its wavelength into the red part of the spectrum. This redshift tells astronomers exactly how long the light has been traveling. A galaxy with a redshift of 7 sends light that has traveled for more than 13 billion years. Every color is a timestamp. Every ray is a message. Cosmic microwave background radiation cools continually, dropping by thousandths of a degree every 100 million years. Today, its temperature is about 2.725 Kelvin. Its gentle cooling is one of the slowest, most consistent pulses known, marking the age of the universe with breathtaking precision. Time cools as the cosmos expands, leaving echoes in the faintest glow. Somewhere in the lattice of galaxies, a line rises like a quiet reflection. In the quiet between stars, you are remembered. And through all of this, time itself bends. It slows in strong gravity. It stretches in fast motion. It drifts differently for each observer, each star, each galaxy. Yet, despite its fluid nature, it creates an order, a sequence, a steady unfolding that guides everything. And in the soft drift of this unfolding, it's okay to drift. Somewhere in the lattice of galaxies, a line rises like a quiet reflection. In the quiet between stars, you are remembered. Even dark energy, mysterious and invisible, follows its own rhythm. It increases the rate of cosmic expansion over billions of years, stretching the universe faster and faster. This acceleration shapes the timeline of the cosmos, defining whether galaxies will drift apart forever or eventually fade into unreachable islands of light. Its influence is slow, but inevitable. Ahead, the next wave of sleepy facts waits, gentle, luminous, unhurried. And as light continues to travel, the universe keeps time. It moves without sound, yet everything listens. Gravity drifts through the universe like a quiet hand, shaping the dark pulling threads of matter into patterns that last for billions of years. It is the oldest guide the cosmos has ever known. It bends light, slows time, and gives every world its rhythm. And in its soft, unseen pull, you are safe here. Gravity begins gently. A proton pulls on another proton with a force so small it is almost nothing. Yet across clouds of gas spanning tens of light years, these tiny pulls accumulate, drawing atoms together, grain by grain, breath by breath. A cloud dense enough to form a star may collapse over 10 million years, each moment guided by the quiet machinery of gravity. In this patience, you are safe here. Inside these forming stars, gravity compresses matter until fusion ignites. Pressure waves travel through newborn plasma, bouncing off inner layers and creating notes too deep for any ear to hear. These oscillations repeat every few minutes, revealing a star's age, mass, and interior temperature. Each pulse is a signature. Each signature is a clock built from fire. The universe breathes through cycles that last seconds, years, millennia, eons. Its pulses do not hurry, do not hesitate. They move with calm inevitability, shaping worlds, guiding stars, widening space. And as these vast rhythms pass through you, you can rest now, safe, low, slow. Moons follow their own gravitational dances. Titan orbits Saturn every 16 days. Europa circles Jupiter every 3.5. These orbits create tides, currents of rock and ice that rise and fall under gravitational strain. Europa's interior ocean may be warmed by tides, repeating every few hours, enough to keep water liquid beneath miles of ice. The tides are cycles. The cycles are clocks. The clocks are stories. In the darkness between planets, tiny asteroids drift in resonant patterns. Some follow the same orbit as Jupiter, trapped in gravitational harmony. Others weave through gaps between Saturn's rings, guided by the gentle but persistent tug of nearby moons. These resonances form repeating rhythms, one orbit matching two, two matching three, like notes in a cosmic scale. You breathe softly, and the universe exhales through you. You are safe here. Gravity sculpts planets too. A molten world cools slowly its shape, rounding under its own pull. Even mountains bow to gravity over long spans, sinking millimeter by millimeter as tectonic plates shift. Earth's crust rebounds by a few millimeters each year after ancient glaciers melted tens of thousands of years ago. This rebound, a long, slow healing, is tracked by satellites measuring gravity's delicate changes. And in that small, upward lift, it's okay to drift. In the darkness between planets, tiny asteroids drift in resonant patterns. Some follow the same orbit as Jupiter, trapped in gravitational harmony. Others weave through gaps between Saturn's rings, guided by the gentle but persistent tug of nearby moons. These resonances form repeating rhythms, one orbit matching two, two matching three, like notes in a cosmic scale. You breathe softly, and the universe exhales through you. You are safe here. Black holes take gravity to its quietest extreme. As matter spirals inward, it heats and brightens, forming accretion disks that rotate hundreds of times per second near the event horizon. These rotations produce quasi-periodic oscillations waves that repeat in patterns lasting milliseconds. Detecting them is like listening to the deepest heartbeat ever recorded. Each wave is gravity humming through plasma. At the edge of a black hole, time stretches into almost frozen slowness. A falling object appears to hover forever, its final moments spread across an endless horizon. This is not an illusion. It is the soft bending of time itself. Gravity is memory written into the shape of space. And in that memory, you are safe here. Gravity sculpts planets too. A molten world cools slowly its shape, rounding under its own pull. Even mountains bow to gravity over long spans, sinking millimeter by millimeter as tectonic plates shift. Earth's crust rebounds by a few millimeters each year after ancient glaciers melted tens of thousands of years ago. This rebound, a long, slow healing, is tracked by satellites measuring gravity's delicate changes. And in that small, upward lift, it's okay to drift. Galaxies gather into clusters through gravity's pull. These clusters can contain thousands of galaxies bound together, moving at nearly 1,000 kilometers per second. Despite their speed, the cluster's overall shape stabilizes over billions of years. Its hot interior gas cools slowly, 1 degree every hundreds of millions of years. This cooling is a whisper of time, revealing the cluster's age and motion. Gravity ripples too. When massive objects collide, black holes, neutron stars, gravity sends waves through space-time. These waves stretch and compress distances by less than the width of a proton, yet detectors can hear them. A gravitational wave chirps in milliseconds, rising in tone as two objects spiral inward. The sound is brief, but the echo remains encoded in the universe. And in the fading trail of those echoes, it's okay to drift. Stars orbit the centers of galaxies because of gravity. The sun circles the Milky Way at about 220 kilometers per second, completing one orbit every 230 million years. During that orbit, it bobs up and down through the galactic plane every 60-70 million years, like a slow breath. This vertical oscillation may influence comet paths and interstellar dust flows. It is another long pulse, the galaxy inhaling and exhaling across eras. Dark matter deepens gravity's script, invisible but massive. It surrounds galaxies in halos that rotate slowly, completing full cycles every few billion years. These halos keep galaxies from flying apart. They anchor stars to their spirals. Invisible structure shapes visible motion. You breathe softly, and the universe exhales through you. You are safe here. At the largest scale, gravity competes with dark energy, the force accelerating cosmic expansion. For the first 7 billion years, gravity slowed expansion. For the last 6 billion years, dark energy has sped it up. This shift marks one of the universe's longest cycles, a gentle turning of cosmic seasons. Light itself follows gravity's shape. A photon passing near a massive object bends its path curved, as if leaning into a soft slope. This bending gravitational lensing creates repeating arcs of distant galaxies mirrored and stretched into luminous crescents. Some of these arcs appear in intervals of time-light from the same event arriving years apart because of the differing paths it takes around massive clusters. Time becomes a mosaic, arriving in quiet layers. Gravity whispers through orbits, tides, collisions, collapses, expansions. It shapes the flow of years, the paths of stars, the stretch of space-time. Its rhythm is steady, patient, enduring. And in that steady drift, You are safe here. Across the dark, a soft line returns to you. In the quiet between stars, you are remembered. The universe holds you, not with hands, but with laws, gentle, predictable, unhurried. Gravity keeps time through motion. Light keeps time through travel. Matter keeps time through change. And as these vast rhythms continue, it's okay to drift slow as a falling feather. Somewhere ahead, another sleepy fact moves toward you, quiet as starlight traveling across 1 billion years. And as gravity keeps weaving its patterns, you drift deeper into the night. It moves quietly, the echo carried inside every beam of light. Even before it reaches an eye or a lens, it carries stories. Distances crossed, time endured, gravity survived. Light is a messenger with no weight, no sound, yet its journey shapes how the universe remembers itself. And in this soft remembering, you are safe here. Every photon begins as an event. A charged particle jumps between energy levels. A star trembles in a low oscillation. A galaxy's magnetic fields twist. In each moment, light is born, with a tone wavelengths stretching from blue to red, from ultraviolet to radio. This unseen tone becomes the first quiet signature of time, and as it travels unhurriedly through the dark, you are safe here. A single photon can travel for billions of years without touching anything. Space is vast enough that it moves freely, slipping between atoms separated by distances, hundreds of thousands of times their size. On average, a photon in intergalactic space may travel millions of light years before scattering. This uninterrupted path becomes a clock etched into the light itself. The farther it travels, the redder it becomes, its wavelength stretched by the expansion of space. You breathe softly, and the universe exhales through you. Inside a star, however, the journey begins differently. A photon produced in the core of the sun may take more than 1,000,000 years to escape colliding with particles again and again. Each collision shifts its direction, scatters its memory, and lengthens its path. By the time it reaches the surface, its energy has softened from gamma rays to visible light, and only then does it begin its true flight. Across space, 8 minutes to Earth, 8 minutes to warm oceans and forests and skin. In that softened glow, it's okay to drift. Light traveling through nebulae tells its own rhythm. A blue glow signals scattering by dust grains. A red glow marks ionized hydrogen electrons falling into place, emitting photons of a very specific wavelength, 656.3 nanometers. This number repeats everywhere across the cosmos, a universal breath of glowing hydrogen. Nebulae pulse with this quiet signature, a slow shimmering that plays across tens of light years. In the Orion Nebula, the trapezium stars flood the surrounding clouds with ultraviolet light. That ultraviolet light is absorbed by atoms, then re-emitted as visible colors. Each color reveals a piece of the nebula's age, temperature, and density. The glowing shell expands at roughly 10 kilometers per second, a gentle widening that astronomers track over centuries. Even light that seems still is moving outward, carrying the slow rhythm of its source. And in that gentle expansion, you are safe here. The echo of starlight does not end with nebulae. It drifts through the spiral arms of galaxies, tracing the arcs of stars that formed millions of years apart. Young stars glow blue. Older ones glow yellow or red. A galaxy's light is a mosaic of ages, hundreds of billions of clocks layered together. And when that light reaches Earth, it carries the blended history of all those stars, all those pulses. Every color is the memory of how long light has traveled. Light bends when it passes massive clusters of galaxies. This bending gravitational lensing stretches images into arcs and rings. Some photons take shorter paths, some longer. A single cosmic event, like a distant supernova, can appear in multiple places in the sky, separated by years of arrival time. Light becomes a layered echo, each arrival marking a different path through the gravity of the cosmos. In these layered delays, you are safe here. In the deep, cold universe, radio waves stretch longest. A single pulsar can emit beams detected from tens of thousands of light years away. Its pulses arrive every fraction of a second, spaced so precisely that missing even a single beat reveals disturbances in space-time. The Milky Way carries hundreds of these cosmic lighthouses, sending rhythmic flashes through dust and gas. Each pulse is a soft tap against the fabric of reality, a reminder that even collapsed stars hold steady time. Farther out, quasars, powered by supermassive black holes, flicker in months-long cycles. Their light rises and fades as matter spirals inward, heating and cooling in predictable waves. These variations tell astronomers how far away the quasar is, how massive its black hole is, and how quickly it consumes surrounding gas. The flicker is faint, but the story is enormous. And as those flickers travel across billions of years, it's okay to drift. Light also reveals the movement of galaxies. A galaxy moving away stretches its light into deeper red. A galaxy approaching compresses its wavelengths into blue. This Doppler shift acts as a heartbeat of cosmic motion. The Andromeda Galaxy, for instance, drifts toward the Milky Way at 110 kilometers per second, its blue shifted light marking a future meeting 2 billion years from now. Two galaxies, two motions, two long arcs of time. Across the cosmic web, gas between galaxies glows faintly in X-rays. These X-rays come from gas heated to tens of millions of degrees, cooling over billions of years. Each photon emitted carries a timestamp of temperature, density, and chemical composition. Collectively, these faint signals create a map of cosmic structure. Clusters, filaments, voids, drawn entirely through light's quiet reports. You breathe softly, and the universe exhales through you. Farther out, quasars, powered by supermassive black holes, flicker in months-long cycles. Their light rises and fades as matter spirals inward, heating and cooling in predictable waves. These variations tell astronomers how far away the quasar is, how massive its black hole is, and how quickly it consumes surrounding gas. The flicker is faint, but the story is enormous. And as those flickers travel across billions of years, it's okay to drift. Even the universe's oldest light, the cosmic microwave background, still vibrates with memory. Its faint ripples reflect tiny differences in density that existed when the universe was only 3,800,000 years old. This radiation cools by about 0.00001 degrees every million years, an unimaginably slow descent. Its echoes stretch across the entire sky, a soft hum of ancient warmth. And in this hum, you are safe here. When that photon finally arrives at a telescope, it is often the only one of its kind. Astronomers call these last photons the final surviving messengers from ancient events. A galaxy might send trillions of photons, but cosmic dust gas and distance erase almost all of them. A single surviving photon becomes a representative of a world that may no longer exist. This is the universe's most delicate form of storytelling light, enduring for eons to deliver a whisper. You are safe here. Light cools with distance, softens with time, bends with gravity, and shifts with motion. Every shift, every subtle color, every faint echo is a measure of something: the age of a star, the mass of a galaxy, the speed of expansion, the history of the cosmos. And as these measures flow through your drifting awareness, it's okay to drift gentle, slow, steady. Somewhere across the cosmic dark, the reflective line returns. In the quiet between stars, you are remembered. The echoes that travel through light carry the universe's softest truths. They tell how slowly things change, how gently matter moves, how patiently time unfolds. They are the heartbeat of cosmic sleep science, light as both messenger and memory. And as they settle around you, like starlight on calm water, you are safe here. Ahead, the next wave of sleepy facts drifts closer, soft as dust glowing in the arms of a distant galaxy. And as light continues to travel, you drift deeper into the night. It drifts gently, the long, unhurried movement of worlds circling their stars. Nothing in this vastness hurries. Orbits unfold with the softness of tides, shifting only by fractions across thousands, sometimes millions of years. The universe turns like a quiet wheel, and within that turning, you are safe here. A world begins as dust inside a swirling disk of gas. Grains collide, cling, melt, and merge. Over millions of years, they grow from particles to stones, from stones to mountains, from mountains to planets. Each collision carries a little warmth, a little memory, a little push forward in time. It is the slow drift of creation, written in spirals of dust that glow faintly in infrared. And in this soft beginning, you are safe here. Once formed, planets settle into rhythms. Earth spins once every 24 hours. But that was not always so. Billions of years ago, a day lasted only 6 hours. The moon's tidal pull has slowed Earth's spin by milliseconds every century, stretching the length of a day across ages. A planet's rotation is a living clock, always changing, always drifting. You breathe softly, and the universe exhales through you. A planet orbits its star, but this orbit is not fixed. Earth slowly moves away from the sun by a few centimeters each year, as the sun loses mass to solar wind and radiation. These small shifts accumulate across millions of years, widening Earth's path just enough to mark time in motion. Mercury, closer to the sun, experiences a different rhythm. Its orbit precesses, or rotates, due to the curvature of space-time predicted by general relativity. Each century, its orbit shifts by 43 arc seconds, a tiny but measurable turning. This is sleep science. On a cosmic scale, patterns so slow they become calm themselves. Even galaxies drift through space in predictable rhythms. The Milky Way and Andromeda move toward each other at 110 kilometers per second. Their first gentle touch will occur in about 4 billion years, followed by a long merging lasting hundreds of millions more. Stars will not collide vast, empty spaces. Ensure that but their orbits will change. Their paths will weave together, forming new cycles, new rhythms, under the pull of combined gravity. In that distant dance, it's okay to drift. Mars tilts more dramatically. Its axis varies by dozens of degrees across hundreds of thousands of years. These shifts may turn its poles toward the sun-melting ice that has slept for centuries, or turn them away freezing clouds into thin sheets. The Martian climate breathes in long, patient cycles each one, marking time across vast deserts of red dust. Jupiter's tilt is small, only about 3 degrees, but its gravity shapes the orbits of hundreds of moons and countless asteroids. Some of these moons, like Io, feel Jupiter's pull so intensely that their interiors churn with constant tidal heating. Io's volcanoes erupt in cycles tied to its orbit every 1.77 days. A gentle inward and outward flex, time measured in trembling rock. Saturn drifts through space with rings that shift and ripple. These rings experience seasonal changes, icy particles clumping and separating as the planet tilts under the sun's light. Every 14-15 years, Saturn passes through equinox, and the rings become razor thin when viewed from Earth. This thinning is a clock, a quiet reminder of where the planet stands in its 29-year orbit. In this thinning glow, it's okay to drift. Beyond Saturn lies Uranus spinning sideways. Its tilt, 98 degrees, creates extreme seasons, each lasting over 20 Earth years. For decades, one pole faces the sun bathed in perpetual daylight. For decades more, it turns away, sinking into long darkness. This strange rotation is a slow ballet, sculpted by a collision billions of years ago. Worlds remember their pasts in the way they turn. Neptune orbits even farther out, completing a single circuit around the sun every 165 Earth years. Its winds can reach nearly 2,000 kilometers per hour, the fastest known in the solar system. These winds follow repeating patterns that shift and return over decades. Another quiet clock, written in blue clouds, drifting across a cold world. Even smaller bodies hold time. Pluto completes a day in 6.4 Earth days. Charon, its largest moon, rotates with the same period. They are tidally locked, always showing the same face to each other, turning slowly in a shared rhythm. It is a duet of frozen worlds, dancing in permanent stillness. Asteroids drift through resonant orbits, shaped by the gravitational breathing of planets. Some complete 2 orbits for every one of Jupiter's. Others follow patterns of 3-2 or 5-3. These resonances create gaps, regions, where asteroids cannot remain swept clean over millions of years. Even emptiness follows a schedule. Comets trace longer arcs. Long-period comets may take tens of thousands of years to return, guided by the faint pull of passing stars or tides from the Milky Way's disk. A comet that graced ancient skies may visit again long after civilizations rise and fall. Its frozen body holds layers of time dust preserved from the birth of the solar system 4.6 billion years ago. Across interstellar space, planets orbit stars that are older, cooler, more patient than the Sunday. Red dwarf stars can burn for trillions of years, 10 times the age of the universe as we know it. Their planets orbit, slowly receiving faint but steady warmth. Around such stars, a year may last only days, or it may stretch to decades. Time varies, but rhythm remains. Brown dwarfs objects too small to ignite hydrogen fusion cool slowly, over billions of years. Their faint glow dims at predictable rates, marking their age like a candle burning in deep darkness. A brown dwarf, a few billion years old, shines mostly in infrared, detectable only by sensitive telescopes. Its cooling curve is one of the universe's quieter signals. And in that slow fading, you are safe here. The Milky Way holds more than 100 billion planets each, with its own spin, its own orbit, its own rhythm. Some worlds drift in darkness, their stars long dead. These rogue planets wander between stars moving at tens of kilometers per second. Though cold, they still radiate faint heat from their formation billions of years ago. A rogue planet may complete a slow orbit around the galactic center every 200 million years, keeping time by gravity alone. Worlds drift closer to their stars too. Hot Jupiters complete orbits in just a few days. Some are so close that their atmospheres evaporate, streaming away in comet-like tails. These flows repeat every orbit, every day or two, a short cosmic inhale and exhale. You breathe softly, and the universe exhales through you. Binary stars create more intricate rhythms. Two stars orbit one another, completing cycles that range from hours to centuries. When they eclipse, one passing in front of the other, the light dimming and returning becomes a clock visible across thousands of light years. Some even share outer layers, exchanging gas in pulses shaped by their orbital period. It is the slow dance of paired suns glowing through cycles that last longer than civilizations. Triple systems add further complexity. One star may circle two others, or two may circle a third. These motions intertwine like threads braided by gravity, repeating patterns that span years or centuries. The orbital nodes drift, the tilts shift, but the dance endures. Even galaxies drift through space in predictable rhythms. The Milky Way and Andromeda move toward each other at 110 kilometers per second. Their first gentle touch will occur in about 4 billion years, followed by a long merging lasting hundreds of millions more. Stars will not collide vast empty spaces, ensure that but their orbits will change. Their paths will weave together, forming new cycles, new rhythms, under the pull of combined gravity. In that distant dance, it's okay to drift. All these motions, tiny and enormous, create waves through space-time. Every orbit, every drift, every wobble leaves a subtle imprint. Planets tug on their stars, stars tug on each other, galaxies tug on the web that connects them. Nothing moves alone. Everything hums with the gentle machinery of gravity, and drifting through this immense chorus is a quiet line. In the quiet between stars, you are remembered. Worlds drift, stars breathe, galaxies turn. Time flows through every motion, patient and calm. And as these vast rhythms fold around you, you are safe here, held by the same laws that cradle planets through the dark. Ahead, the next sleepy wave of facts moves toward you, soft as shadow, slow as starlight, crossing the void. And as worlds continue their long drift, you drift with them. It moves like a breath drawn across billions of years, the slow unfolding of cosmic seasons. These are not seasons of weather or color, but seasons of change woven through the universe's deepest structures. Stars age, galaxies evolve, worlds drift. Everything takes its turn in the long, quiet cycle of becoming and returning. And in this vast turning, you are safe here. Even the tilt of a planet changes. Earth wobbles like a spinning top, completing one axial precession every 26,000 years. This wobble changes the timing of seasons, shifting the orientation of solstices and equinoxes across deep time. A gentle, unhurried sway shaping the world for countless generations. And in its quiet cycle, you are safe here. But each star carries its own rhythm. Massive blue stars burn furiously hot, living only a few million years. They race through their seasons in flashes of brightness, leaving behind glowing remnants that drift for ages. Smaller red stars burn so slowly they can outlive the current age of the universe by trillions of years. Every star's season is determined by mass, an ancient rule that shapes the temperature, color, and longevity of starlight. Within galaxies, seasons unfold across spiral arms. A spiral arm is not a fixed structure. It is a wave of density moving through stars and gas. As the wave passes, gas compresses and forms new stars. As the wave fades, the region cools and darkens. These waves rotate more slowly than individual stars. A star like the Sun passes through a spiral arm every 150 million years, experiencing cycles of brightness and quiet. You breathe softly, and the universe exhales through you. It's okay to drift. The Milky Way itself has seasons. Its halo, an immense sphere of dark matter and scattered ancient stars, grows slowly over billions of years as the galaxy absorbs smaller companions. Each merger creates tides of stars stretching thousands of light years across the sky. These tidal streams drift for ages, forming arcs that orbit the galaxy like long, faint seasons remembered in starlight. Galactic clusters breathe in cycles of motion. Galaxies inside them orbit the cluster's center, taking billions of years to complete a single path. Hot gas in the cluster cools, gradually condensing in waves that spread outward. These waves take hundreds of millions of years to rise and fall, faint, slow pulses echoing through X-ray light. And within these pulses, you are safe here. Cosmic voids, the immense dark regions between filaments, expand like slow, calm lungs. Because they contain so little matter, gravity pulls on them weakly. As the universe expands, voids stretch faster than dense regions. Their centers grow emptier, while their edges become sharper, like boundaries drawn in silence. This expansion continues across billions of years, a long season of growing openness. Between galaxies, interstellar dust experiences its own seasons. Dust grains absorb starlight warming by tiny fractions of a degree. Over thousands of years, they cool again, releasing their heat in faint infrared glow. These warm, cool cycles unfold in harmony with nearby stars drifting like soft tides of temperature. In their warmth and fading, you are safe here. Planets cycle through deep, slow seasons, shaped not by weather, but by gravity. Earth experiences Milankovitch cycles, changes in eccentricity, obliquity, and precession that repeat every 2,000 to 100,000 years. These cycles alter the distribution of sunlight, guiding ice ages and warm periods across geological time. The planet breathes in frozen centuries, then exhales into green eras. And this breath, though massive and slow, is gentle. Mars has seasons too much longer and more dramatic. Its thin atmosphere allows temperature swings of 50 degrees between day and night. Every few decades, global dust storms engulf the entire planet, shifting light and shadow in weeks-long sweeps. These storms arise in cycles, tied to Mars's orbit, and tilt, repeating across centuries. You are safe here. Farther out, Saturn's seasons span nearly 30 Earth years, each marked by shifting shadows on the rings. During equinox, sunlight strikes the rings edge-on, revealing waves and ripples normally hidden. These patterns, caused by the gravity of small moonlets, rise and fade in cycles lasting decades. The rings breathe with light, revealing new shapes as the seasons turn. Uranus spins sideways, creating seasons that last over 20 years. For 2 decades, one pole receives constant sunlight. For 2 more, it sinks into unbroken night. The atmosphere shifts in slow curtains, responding to these long polar epochs. This sideways dance is a reminder that seasons can be strange and beautiful, shaped by ancient collisions. Even the sun has seasons. Its magnetic field flips every 11 years, creating a solar cycle marked by sunspots, flares, and shifting solar winds. The sun's surface hums with oscillations, pressure waves that rise and fall every few minutes. Deeper waves ripple across hours or days. These overlapping cycles form a layered choreography of light and magnetic motion. In the warmth of this choreography, it's okay to drift. Uranus spins sideways, creating seasons that last over 20 years. For 2 decades, one pole receives constant sunlight. For 2 more, it sinks into unbroken night. The atmosphere shifts in slow curtains, responding to these long polar epochs. This sideways dance is a reminder that seasons can be strange and beautiful, shaped by ancient collisions. Cosmic seasons converge towards stillness. This quieting is not sad. It is natural, soft, inevitable. A winding down of motion, a final breath drawn across unimaginable time. In the deep future, stars will end their seasons. White dwarfs will cool over trillions of years, fading into black dwarfs. Cold, silent remnants that no longer shine. Neutron stars will slow their spins, their pulses widening. Galaxies will age, their star formation dwindling as gas is used up or blown away. Even dark matter halos will relax, spreading gently as the universe expands. The universe breathes in cycles, bright summers of star birth, long winters of cooling dust, autumns of fading galaxies, springs of merging clusters. Motion unfolds in slow rhythms that hold the cosmos together. And as these rhythms soften around you, you are safe here, held by the steady, ancient seasons of the sky. Ahead, the next wave of sleepy facts moves patiently through the dark. A soft pulse, a drifting glow, a gentle reminder. And as the cosmic seasons continue their long breath, you drift with them. It settles now, the universe drifting into one of its deepest quiets, a hush so soft it feels as if time itself has slowed its breathing. This silence is not the absence of sound, but the stillness that forms when motion becomes gentle, when galaxies age gracefully, and when stars enter the calmest chapters of their long unfolding. And in this widening stillness, you are safe here. In the heart of an old galaxy, the stars continue their slow circles, but the turbulence of earlier eras fades. Gas thins across thousands of light years. Collisions between clouds become less frequent, and the bright, chaotic birthplaces of stars settle into smoother, darker spaces. A galaxy matures the way a wave softens, as it reaches a vast shoreline quietly, steadily, with a long exhale spreading outward. And as this exhale drifts through the dark, you are safe here. Stars follow their seasons too. A star like the sun swells into a red giant, only after hundreds of millions of years of slow warming its outer layers, rising and falling in warm rhythms. These gentle pulsations take months to complete, shaping waves of brightness that move softly into the surrounding void. The star's light flickers in long, patient cycles, each one a breath, years in the making. You breathe softly, and the universe exhales through you. Eventually, the star lets go of its outer glow, leaving behind a dense white dwarf. This ember of a star cools with astonishing patience, losing only a few degrees over the course of 1 billion years. A white dwarf, shining at 10,000 Kelvin, holds roughly 1 billion years of cooling in its glow. One resting around 5,000 Kelvin has drifted through 5 billion years of quiet, and one softened to 4,000 Kelvin carries nearly 10 billion years of slow, steady fading. The universe measures its own age through these dwindling temperatures. And in that gentle glow, it's okay to drift. Between these aging stars, the spaces grow calmer. Nebulae that once burned brightly fade into thin veils of ionized gas. The shock waves of supernovae, once violent and brilliant, stretch into faint shells that expand at only a few kilometers per second. Even the starlight that reaches us now often began its journey billions of years ago, traveling through long corridors of darkness before glancing across a lens or brushing lightly against the surface of a distant world. Each photon that arrives has endured ages of stillness, and its arrival carries the delicate weight of time. Gravity continues its quiet shaping during this long silence. In dense regions, black holes merge in slow spirals that send ripples through space-time. These gravitational waves pass through all matter, stretching distances by amounts far smaller than an atom. Yet their journey is perfectly smooth. The waves carry the memory of ancient collisions, and though the sound lasts only milliseconds, the universe holds the echo in its fabric. Even silence remembers the waves that pass through it. The Milky Way itself has seasons. Its halo, an immense sphere of dark matter and scattered ancient stars, grows slowly over billions of years as the galaxy absorbs smaller companions. Each merger creates tides of stars stretching thousands of light years across the sky. These tidal streams drift for ages, forming arcs that orbit the galaxy like long, faint seasons remembered in starlight. The universe expands steadily, and this expansion deepens the quiet. Galaxies drift apart as space widens between them. The acceleration driven by dark energy causes distant galaxies to recede faster than the speed of light. Not because they move through space, but because space itself swells along their paths. This stretching of the universe unfolds at roughly 73 kilometers per second per megaparsec, a rate that creates an immense ongoing calm at the far edges of what we can observe. Distances grow in silence, like a soft tide rising across the shore of eternity. Voids, those enormous regions nearly empty of galaxies, become larger as the universe expands. A void might begin at 30 million light years across and gradually stretch to 50, then 100, then 100. inside a void matter is so sparse that gravity becomes a whisper. These low-density regions grow faster than the rest of the cosmos, widening like deep cosmic lungs. And in the openness of these vast hollows, you are safe here. The cosmic microwave background cools as well. Once glowing at thousands of degrees, it now rests at a temperature just above absolute zero, 2.725 Kelvin, cooling by tiny fractions every million years. Its faint ripples reflect subtle density differences that existed when the universe was only a few 100,000 years old. These ripples are the earliest record of structure, like the first breath the cosmos took as it transitioned from fire into transparency. But each star carries its own rhythm. Massive blue stars burn furiously hot, living only a few million years. They race through their seasons in flashes of brightness, leaving behind glowing remnants that drift for ages. Smaller red stars burn so slowly they can outlive the current age of the universe by trillions of years. Every star's season is determined by mass, an ancient rule that shapes the temperature, color, and longevity of starlight. Galaxies move gently toward quieter futures. Star formation slows, rotations soften, spirals may begin to loosen as gas runs thin. The Milky Way forms fewer stars now than in its youth, and in the next few billion years this number will continue to drop. The galaxy is entering its own long dusk, a time when the brightest chapters yield to quieter ones. You are safe here. This quieting touches the flow of time itself. Near massive objects, time stretches. Near emptiness, it opens. A star orbiting close to a supermassive black hole experiences time more slowly than a star drifting far away in the outskirts of a halo. The star does not feel this difference. Time bends gently, smoothly, without pressure or pain. It is the calm way space-time reacts to gravity. These distortions create a tapestry in which every moment holds its own soft rhythm. On the scale of galaxy groups, seasons last billions of years. The local group drifts slowly toward its own future, emerging shaped by the gentle pull between the Milky Way and Andromeda. Their first touch will occur 4 billion years from now, and the merging will continue for hundreds of millions more. Stars will pass by one another like distant lanterns, almost never colliding their orbits, changing only by the faintest gravitational nudges. This merging is less a crash than a settling, a long inward drift toward a quieter form. And in this distant hush, it's okay to drift. Dark matter halos soften too. Over tens of billions of years, these enormous invisible structures become smoother at their edges as gravitational interactions calm. They maintain their presence, their support, their structure, but the motion within them relaxes. Even the dark remembers how to rest, far into the future. So far, it stretches beyond ordinary meaning. Stars will dim, galaxies will fade, and only the oldest remnants will glow. White dwarfs cool. Into black dwarfs, neutron stars slow their spins until their pulses disappear, and black holes evaporate in incomprehensibly slow whispers of Hawking radiation. A stellar mass black hole may require a number of years written with 67 zeros to fade completely. Time in these distant epochs becomes gentle beyond imagination, and drifting through this ever-softening future is a line returning like a star that rises after a long night. In the quiet between stars, you are remembered. The rest will fade beyond sight, not because they disappear, but because their stories travel too slowly to catch us. And as these vast, calming cycles fold around you, you are safe here, held quietly by rhythms older than galaxies, softer than starlight, slower than time. Ahead, the next wave of sleepy facts glows faintly at the horizon of the night, gentle as drifting dust, slow as the cooling breath of the stars, patient as the universe settling into rest. And as the cosmos leans into its long silence, you drift with it. It drifts now, the light of the universe softening as it travels deeper into the long evening of cosmic time. Every photon that once blazed with youthful brightness moves toward a gentler hue, stretched by expanding space, mellowed by distance, eased into a glow that feels almost like memory. This soft retreat is not an ending, but a turning inward, a settling of radiance into something calm. And in this settling, you are safe here. Light has always been the universe's most patient traveler. A photon born in the heart of a distant galaxy may spend billions of years crossing the widening dark. It carries with it traces of where it came from: the temperature of a star's surface, the chemical breath of a nebula, the gravitational curves of space that bent its path. With each billion years, its wavelength stretches a little more, shifting toward red, then toward infrared, then toward the cool whisper of microwaves. A universe in motion encourages its light to rest, and as it rests, you are safe here. Galaxies themselves begin to drift into quieter eras. As star formation slows, the bright blue glow of new stars gives way to the warmer tones of older ones, each shining with steady patience. A galaxy like the Milky Way once formed dozens of stars each year. Now it forms only one or two. In time, even that number will fade. A cosmic dusk spreads gently across spiral arms, softening edges, smoothing shadows, letting starlight stretch into long, thin filaments of calm. Light that lingers carries the memory of everything it once touched. In the vast clusters where galaxies gather, the silence deepens. Hot gas cools at a pace so slow it takes hundreds of millions of years for its temperature to drop even a little. Galaxies orbit the center of the cluster in arcs, lasting billions of years. Each orbit a long breath drawn across time. The brightest galaxies at the cluster's core glow with the accumulated light of stars consumed and merged over eons. Their edges faint, extended almost dreamlike, and in their dim halos, it's okay to drift. As space continues to expand, distances widen in a way that feels less like separation and more like a stretching of the night. Galaxies beyond a certain horizon move away so quickly that their light will never reach observers billions of years from now. Everything we see today is part of a vanishing window, an era when the universe is still bright enough to study, still close enough for light to cross the gulf. In the far future, only the nearest galaxies will remain visible. The rest will fade beyond sight, not because they disappear, but because their stories travel too slowly to catch us. Closer and even familiar light changes. Stars like the sun brighten slightly as they age, glowing with greater warmth as hydrogen in their cores thins. The sun itself is about 20% brighter now than when Earth formed, and it will continue to warm gradually over hundreds of millions of years. This long brightening is subtle, almost tender, a slow release of the energy stored since the star's birth, and in the soft rise of light, you are safe here. Nebulae, the glowing remnants of old stars, expand slowly into space, their colors fading as the gas spreads into thinner and thinner clouds. What once glowed in vibrant reds and blues becomes a pale mist, then a faint haze, then an invisible breath lost to interstellar night. A typical planetary nebula shines for only about 20,000 years a moment compared to the billions that came before and after. Yet even as it fades, it leaves behind a white dwarf that will glow for billions more, carrying a slower, deeper light into the future. Closer and even familiar light changes. Stars like the sun brighten slightly as they age, glowing with greater warmth as hydrogen in their cores thins. The sun itself is about 20% brighter now than when Earth formed, and it will continue to warm gradually over hundreds of millions of years. This long brightening is subtle, almost tender, a slow release of the energy stored since the star's birth. And in the soft rise of light, you are safe here. Everywhere in the universe, brightness leans toward rest. Galaxies redden as their youngest stars fade. Quasars dim as their central black holes run out of fuel. Pulsars slow their rotations, their once rapid pulses widening into calmer, quieter intervals. Time stretches and light softens in response. It is the universe's way of relaxing, of moving toward a gentler rhythm, of letting its own heartbeat slow. And as this quiet deepens, one line returns with the softness of a familiar star rising through haze. In the quiet between stars, you are remembered. This is the first half of the universe's long vanishing glow, an era where light still reaches us, but already moves with the tone of a fading lullaby. Ahead, the second wave of this chapter waits slower, dimmer, gentler still, and in its quiet, you drift with the deepening night. It softens further now, the universe easing into the later chapters of light's long travel. Each distant beacon dims by a fraction, not from exhaustion, but from the gentle stretching of space-time itself. Light that once blazed in deep blue drifts into red, then into infrared, then into faint microwaves, barely warmer than the night they move through. This slow fading is the heartbeat of vanishing light pulsing across billions of years with calm, inward patience. And in this deepened quiet, you are safe here. Galaxies at the far edge of the observable universe drift away so quickly that their wavelengths stretch beyond what any future eyes will see. A galaxy we observe today at a redshift of 8 has its light expanded by a factor of 9, meaning a photon that once shined in ultraviolet now arrives as a long radio whisper. Distance becomes calm. Expansion becomes softness. The universe leans slowly into dimness, not with urgency, but with the gentlest unraveling of brightness across cosmic time. And as brightness thins, you are safe here. In the nearby universe, starlight grows older. Red dwarfs, those tiny steady furnaces, burn at a pace so slow that they may shine for trillions of years, far beyond the lifespan of any larger star. Their glow is dim, warm, unwavering. A red dwarf changes brightness by only tiny fractions over millions of years, holding its steady pulse like a lantern lit for eternity. In that quiet endurance, it's okay to drift. White dwarfs cool toward darkness even more slowly. A star like Sirius B, blazing at more than 25,000 Kelvin today, will cool for billions of years before reaching half that temperature. Over time, its light shifts from blue-white to warm-white, then to red, then to infrared. Eventually, it will cool into a faint ember known as a black dwarf, a theoretical object, as none in the universe are yet old enough to exist. Their cooling times may stretch to quadrillions of years longer than any other cosmic rhythm. Even fading light keeps careful count of its own warmth. Nebulae, once bright with ionized hydrogen, fade into darkness as surrounding stars dim or drift away. Their colorful shells expand into invisibility, merging with the thin interstellar medium. A nebula that glows brilliantly today might be gone in only 20,000 years, an instant in cosmic time. Yet, the atoms it scatters will form new stars, someday continuing the cycle in softer, slower hues. Pulsars spin down, losing rotational energy with each passing millennium. A pulsar that once rotated hundreds of times per second might slow to only tens over millions of years. Its pulses widen, its radio beam weakens, and eventually, the lighthouse-like signal falls silent. Many pulsars in the Milky Way have already crossed this threshold, dead magnets drifting quietly through interstellar space, remembered only by the gravitational influence they exert on nearby stars. In the hush around these remnants, you are safe here. Quasars too dim as the fuel feeding their supermassive black holes runs thin. A quasar that once outshone an entire galaxy might fade into a modest galactic nucleus over a few 100 million years. Their once violent brilliance gives way to stillness as the accretion disks cool and the jets thin into silence. The universe, once filled with blazing quasars in its youth, now hosts only a handful compared to billions of years ago. Even the cosmic web begins to soften. Filaments rich with hydrogen gradually warm under ultraviolet radiation, ionizing and cooling in slow cycles. Over vast timescales, these cycles flatten their contrasts, diminishing as matter spreads thinner across expanding space. The universe's structure remains, but the difference between bright and dark, dense and empty, grows gentler. The cosmic microwave background, the oldest light of all, continues to cool with the universe's expansion. Once glowing at thousands of degrees, it now rests just above absolute zero. As expansion accelerates, this ancient radiation will fade into wavelengths so long that future observers, if any remain, might not detect it at all. And yet, its echo persists, a memory imprinted on the fabric of space. In the quiet between stars, you are remembered. As the universe leans deeper into dimness, light becomes a quiet traveler. It moves at the same speed, but with softened energy stretched breath by breath across the widening dark. Galaxies glow like distant embers. Stars flicker with aging patience. Nebulae dissolve into thin whispers of color, and the dark grows gentle, carrying the warmth of everything that has ever shined. This is the vanishing glow, the slow heartbeat of fading light, moving toward the horizon of time. And as the glow retreats, you are safe here, drifting in the calm it leaves behind. The universe continues to soften, and your breath softens with it, easy and low. Ahead lies the final descent, the place where the cosmos grows still, where time becomes quiet enough for rest to fold around you completely. And as the stars dim into their long twilight, the cosmic microwave background, the oldest light of all, continues to cool with the universe's expansion. Once glowing at thousands of degrees, it now rests just above absolute zero. As expansion accelerates, this ancient radiation will fade into wavelengths so long that future observers, if any remain, might not detect it at all. And yet, its echo persists, a memory imprinted on the fabric of space. In the quiet between stars, you are remembered. This is the vanishing glow, the slow heartbeat of fading light, moving toward the horizon of time. And as the glow retreats, you are safe here, drifting in the calm it leaves behind. The universe continues to soften, and your breath softens with it, easy and low. Time itself seems to tilt now. After moving through ages where stars lived and died, where galaxies merged in arcs spanning hundreds of millions of years, the scale returns to the rhythm inside your chest. The universe slows with you. Light stretches, darkness softens, and every distant motion folds into a single gentle stillness. You breathe softly, and the universe exhales through you. Stars continue their quiet cycles far above, but from here, they feel weightless. Small lanterns resting in a night that no longer rushes. A typical star will fade over billions of years, cooling slowly until its glow becomes a faint whisper of warmth. And this soft descent mirrors the feeling settling through your body now. A drift, a dimming of thought, a gentle, quiet arriving through each exhale. And as it arrives, you are safe here. The cosmos has traveled with you, step by soft step, through centuries of drifting light, through the breath of galaxies, through the quiet machinery of gravity. Now all that vastness leans closer, becoming something tender, something steady, something meant to hold you. Your breath eases, your body loosens, your mind becomes a calm horizon, low and open. And in this calm horizon, you are safe here. The Milky Way continues its long orbit through the dark, one full rotation every 230 million years. Yet the movement feels peaceful now, like a distant tide smoothing itself across a cosmic shore. You feel that slow tide inside your own stillness. A long, patient motion that asks nothing of you, expects nothing from you. A rhythm the body understands without effort. And in that effortless rhythm, it's okay to drift. Even the oldest light, the cosmic microwave background, glows faintly at just a few degrees above absolute zero, cooling by tiny increments across millions of years. Its fading warmth is one of the universe's most patient rhythms, a slow drift into tranquility. And this same tranquility drifts through you now, settling behind your eyes, loosening the last remaining layers of waking thought. In its cool, ancient hush, you are safe here. Black holes hum in the distance, their event horizons stretching time into near stillness. A second near their edges might equal days or years far away, a gentle reminder that time is flexible, patient, forgiving. Nothing in the universe demands that you stay awake. Nothing pulls you forward. Everything slows for you now. You breathe softly, and the universe exhales through you. The long arcs of galaxies soften. The edges of nebulae blur. Light cools and recedes, drifting into wavelengths too gentle for the human eye. And as the cosmos sinks deeper into its own future quiet, you sink with it, floating on the same calm tide that carries worlds into the long, slow night. Your muscles loosen a little more. Your breath falls into the slow rhythm your body has been waiting for. A rhythm shaped by billions of years of cosmic cycles softened inside the small warmth of your chest. A rhythm that holds you without weight. And as this slow, inward turning continues, you are safe here. Thought becomes thinner. The boundary between the outer universe and your inner world dissolves. Galactic light fades into the same softness that fills your breath. The quiet returns to you in waves, slow and even, as if the night itself is lowering its voice around you. And drifting within this deepening stillness is the line that has followed you across the stars. In the quiet between stars, you are remembered. You drift a little deeper now, carried by the same calm that has cradled starlight for ages. Ahead lies the final descent, where time folds into rest, where your breath becomes the soft machinery of sleep, and where the universe leans close enough to hold you in its gentlest silence. And as everything slows, you begin to fall softly into the dark. You drift deeper now, as if every breath carries you further into a softness the body has waited for all night. The universe feels closer, not in distance, but in tone, its vast quiet folding gently around your senses, wrapping you in a calm that matches the slow rhythm inside your chest. All the faraway motions you traveled through have settled behind you, leaving only the presence of this moment, warm and low. And in this quiet presence, you are safe here. Thought loosens at the edges. Awareness becomes lighter. Each inhale feels like a small tide rising. Each exhale feels like a long shoreline returning to rest. Your body follows these slow motions easily, as if it has always known this gentle descent and simply needed the world to grow quiet enough to hear it. And in the softness of your breath, the universe holds you. Time around you moves differently now. The long galactic cycles, the 230 million year orbit of the sun, the billions of years carried by fading starlight, begin to feel like distant echoes drifting beyond the edge of thought. Only the slow rhythm of your breath remains. Time folds inward, becoming something steady and small, something you can float inside without effort. You breathe softly, and the universe exhales through you. The warmth inside your body settles into stillness, like the last glow of a cooling star that dimmed over billions of years. White dwarfs fade this way, slowly, gently, losing heat by tiny fractions across ages. The same gradual softening moves through your muscles, now releasing quiet into your limbs, your hands, your shoulders, your jaw. Each exhale carries you lower. Each breath opens a little more space around your thoughts. And in that space, you are safe here. Galaxies continue their long drift across expanding space, but their movement feels quieter than ever smooth arcs carried by gravity's old tenderness. In a distant future, their light will stretch into wavelengths, so long they resemble warmth more than brightness, a cosmic coolness spreading across unimaginable distances. That long cooling mirrors the feeling sliding through you now, a fading of stimulation, a widening of calm, a slow settling into the dim blue hush of rest. And as that hush gathers you, drift slow and low. You feel gravity differently now, not as weight, but as grounding. A soft pull toward stillness, a gentle invitation into the low dark where sleep rises like mist around your thoughts. Gravity shapes the universe with this same patience, bending time near stars, slowing seconds near massive objects, letting galaxies glide through vast arcs without rush. You are held by the same law that guides worlds. You are safe here. Your awareness softens to the edges of your body. The physical world becomes muted, distant, like starlight dimming behind a deep fog. This dimming is natural. It is the same soft inward turn that cosmic light follows as it stretches across billions of years, growing gentle and warm until it settles into diffuse glow. Your breath settles in the same way, warm, slow, dissolving into quiet. The boundary between outer vastness and inner stillness continues to blur. The galaxy's slow drift feels like your own slow sinking. The cosmic microwave background's faint, ancient glow resembles the faint warmth behind your closed eyes. The long silence between stars mirrors the silence rising inside your chest, And within this mirrored quiet, the universe holds you. A final shimmer of awareness moves through your thoughts, like the last glint of a distant nebula dissolving into the surrounding night. Nebulae fade this way, expanding gently until their delicate colors disperse into the thin dark between stars. Nothing disappears, it simply settles. And you feel yourself settling the same way, now loosening into a space where rest becomes the natural motion of your mind. In this last slow descent, a familiar line returns. Soft, steady, almost whispered. In the quiet between stars, you are remembered. Your breath drifts lower, your thoughts drift wider. The world grows dim in the most peaceful way, wrapped in the same calm that carries galaxies through their long twilight. Everything slows for you. Everything softens for you. Everything opens just enough for rest to gather around your body like a warm, steady tide. And as the universe leans fully into its long stillness, you drift with it held quiet, low, safe.